Having described in the last two videos the major problems with fusors, a little thought will indicate that there are many machine topologies which haven't been explored yet and which may solve many of these problems. One such example will suffice to illustrate this. Supposing we start with fuel in the middle of a machine, as a solid pellet, a liquid drop, or a capsule of neutral gas. All of these have very high density. This central source can then be vaporized and ionized, for example by a laser, an electrical discharge, or more likely ion beams fired from a periphery into the center. The newly ionized gas, of course, has a very high density and instantly wants to expand outwards because of the electrostatic repulsion between its atomic components. However, this time, because we placed the fuel pellet at the center of a machine, we can actually take advantage of this. In fact, we can aid the expansion outwards by placing acceleration grids to help the expanding ions along and get them up to the required energy of 150 kiloelectron volts. What we have now is a super high density shell of high energy ions traveling outwards towards the periphery of a machine. We can now arrange a target in a spherical shell surrounding all this in an appropriate high density form. This target could again be vaporized or ionized at the correct time if necessary. The particles traveling outwards in the expanding shell then collide with the target, either scattering or fusing. Either way, the particles can then be picked up by energy collectors at the periphery of a machine of the type described in previous videos. So, in this way, by effectively turning the machine inside out, inverting it, with the beam coming from the center rather than from the periphery, and a target on the outside of this, we have potentially solved the two big issues. The pellet and its resulting expanding shell have high energy density, as does the target, and both fused and scattered particles are picked up by energy reclaim around the edges of a machine as a matter of course. I'm not saying that this design is a solution to fusors. In fact, there may not even be a solution if the losses problem proves intractable. But I am pointing out that there are many more innovative designs and topologies like this to try. And given their relative cheapness, much progress could be made on a tiny amount of the budget allocated to magnetic or laser inertial confinement machines. Either way, given the potential of fusion and the budget allocated to other technologies, it's well worth spending some money on fusor technology to establish whether some of these obstacles could be overcome.